Okay, two final examples with regards to identifying linear functions. In this case, we have a table, input, output. The question is, does the relationship defined by the table represent a linear function? So let's just jump right in. Let's start checking our values. I'm going to start here with my -10 to -5. Between these 2 points, this would be 5, going up 5, -5 to 0, that would be another 5. And 0 to 5 is 5. I'm sure I'm tired of saying 5. And 5 to 10 is 5. All right. How about on our outputs? Well, here we went from 8 to 5, so that would be -3. And from 5 to 2, that would be -3. And from 2 to -1, that looks like through -3. And from 1 to -4, that would also be down 3. So we are consistent. On our x values, we're going up by 5. On our y values, we are going down by -3. And we know that this represents a function. All right, because we have a constant rate of change. I'm going to pause here and set up my next problem. And now we have a word problem. We've got a table and it shows the age and the length of a shark over a 15-year period. And question A, what is the rate of change of this linear function? What does this rate of change represent in this situation? That's our first part. And the second is use the growth rate to predict the length of the shark when it is 25 years old and when it is 40 years old. And wow, there's something a little disconcerting to me about the thought of a 40-year-old shark. But moving right along. Okay, so let's see. In terms of our x values, the age in years, that's pretty straightforward because it's going by 5s, right? Between 5 and 10 is 5, 10 and 15 is 5, 15 and 20 is 5. So we know that our x values, our input values, have a constant rate of change between them. Let's look at our output values. And in order to do that, we're going to need to do some arithmetic, which I've already done. And this is what it looks like. Pardon me. It looks like this. I started to subtract between the values. So between the second value, 44.5, and the first, 40.75, that was 3.75. And between the third and the second, that was 3.75. And finally, between the fourth and the third, it was 3.75. So I have a constant rate of change. As a matter of fact, my rate of change is this. It is the length, 3.75, over the years, which is 5 years. So this shark is growing, pardon me, this is going to be in years, and I'm sorry, this is in centimeters. So it's growing 3.75 centimeters every 5 years, and if we simplified that to answer the question about its rate, what's it growing per year, because we're going to need that, I believe, that would simplify by dividing both of these by 5 to 0.75, two equal signs. I think we only need 1 centimeters per year. All right, so it's got a growth rate of 0.75 centimeters per year. And how long will it be when it's 25 years old? Well, I'm going to have to multiply 0.75 by 5, and if I did that and I added it to 52, because that's how old it is, pardon me, how long it is, at 20 years, I would find out that, as you can see, in 5 years it grows 3.75, and let's see, 52 plus 3.75 would equal a grand total of 55.75 centimeters after 25 years. That's how big this thing would be. And if you took this out to 40 years, in other words, if you multiplied this by 3, pardon me, if you multiplied this by 3, right, because 5 years times 3 would be 15 years, and 3.75 multiplied by 3, that would tell you how much the shark would grow in another 15 years. And that would get you up to 40 years. And I'm going to let you do the math. And if you do the math and you come up with 67 centimeters, about, it's an approximate, you'll know that you did it correctly. All right, sorry, you couldn't see that part, could you? That is linear functions, and identifying them and confirming that they are in fact linear functions. All right.